The Sporland division of Parker Hannifin Corporation is sponsoring this podcast. Sporland is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporland maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max Press to Connect, and Zoom Lock Push to Connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporland.com.
I guess that's Jim and John for Sporland signing off.
This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer Oil Float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model. Conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
Going to do any of it, and then they could do it when they get on site.
I'm dying yet. Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. You already sound like you're fired up today. What's going on? Can you talk about it?
Because people can't listen to simple instructions.
Damn it. Damn kindergartners.
Yeah.
I see you're at home, at least.
Yeah, I am finally at home. I've been gone for a month and a half. I was home 5 days in a month and a half.
I know the feeling. I was gone for 4 weeks, and then I was home for a week. And then I had to go back to California to get taught up on that big red trainer that we bought from Danfoss. And that was just utterly amazing. And so I had a ball doing that. And then I was supposed to be home all this week. And then they're like, hey, Oklahoma's fun. Why don't you go up to Oklahoma? I'm like, oh, cool. All right. So I'm up here for the next 2.5 days. I'm going to go home Friday, but that's what I got going on.
Nobody ever said Oklahoma's fun. That's like the Ohio of the South.
It's not really South. It's not South. It's Northish. It's above Texas. Texas is huge. It's like in the middle America. There's that
is the Ohio of the South.
Jesus. You're so awful. We just lost all the Oklahoma listeners. Kevin's just honorary today. So yeah. So actually our next guest, this is something that I've been curious about, Kevin I always wanted to know about, there's an untapped field in refrigeration HVAC that's really not talked about because it's taboo. And I didn't really care. I had a lot of questions about it. So we're going to talk about marijuana grow houses and the cultivating process and basically the temperatures and humidities of all this stuff. And from what I understand, it could be a lot more intricate than what it is currently. So let's talk about it. Maybe we can brainstorm some shit up. So I'm going to bring on Matt and Megan from Mechanical Environments. How we doing?
Hey, guys.
Good. How are you guys doing?
Great. Oklahoma's fun, flat, and Kevin's just having a bad week so far. So
yeah, for the record, I'm from Ohio, so
I'm sorry.
It's okay. You don't offend me.
No, I'm sorry for you being from Ohio.
I only spent my first 31 years there.
If it makes you feel any better, I'm from Pennsylvania, which isn't much better. But I was in the more bustly part. I wasn't like people say Pittsburgh is part of Pennsylvania. It's really not. It's basically more. It's just like Eastern Ohio.
Yeah. It's not fair.
That was an awesome segue. So how are you guys doing this week? You guys just got home.
Oh yeah, super busy. Everybody's getting ready for summer. A lot of prep, a lot of repairs that were being put off until now.
We're busy 7 days a week. We need to hire some more help for sure.
Yeah.
Get some kids and just start cultivating them into this trade.
That's the plan. They got to be 21 to work in the facilities though. So
Really?
Yeah.
Interesting. Tell us a little bit about yourselves. Like, obviously, we now know Megan's from Ohio. Matt, where are you from?
California originally. I've been in Colorado a long time.
Okay. Where'd you guys meet? I'm actually curious, like, how does one like, hey, let's go to Colorado and start a business that just does grows? What do you like? How does that work?
it was a little bit of a journey to get there, but so I'm originally from Ohio. I only got into HVAC about 5.5 years ago.
Okay.
I took a job working for my cousin's husband, who was running one of the parts houses out here. So I started as a territory sales manager for just over 2 years. Then I went and worked for a contractor and did some operations and sales and some field work because controls are apparently hard. And then that was ran by a GC who realized things were harder than they should be. HVAC is hard. So he was like, going to dissolve some of this, but here you go. So we'd already done a year of cannabis at that point. So we already had all the clientele. Might as well keep it going.
Yeah. Really, it was Megan's idea to go full send because a lot of these guys, like, they're just not being taken care of appropriately.
They're not.
Right? A lot of people just see cannabis on the door and try to charge $1 million and nothing ever gets fixed. And there's just a bunch of, it's untapped, right? It's a great service potential because these guys can't be in business without the air conditioners running, right? Without cooling going. So it's just really about like catering to a niche, right? Giving them the priority because a lot of grows hate when you bail because there's a little old lady with no heat. I have product here. This is way more important than that. So it lets us prioritize similar clientele and serve them a lot better than just general.
So I get it. So I used to do very like industrial type refrigeration, and like one of the biggest customers that we had, it was a mushroom farm down in Kennett Square, Pennsylvania. Mushrooms are mushroom. Kennett Square is the mushroom capital of the world over in Pennsylvania, believe it or not. And it's amazing how much heat is generated off the germination of the process of like when they first sprout in that. There's a mass quantity amount of heat that's given off in that first initial process where they're actually, and I'm sure we'll get into it because now I'm thinking about more stuff, but they were actually measuring the soil temperature to make sure it didn't get too hot and actually, so it looks like they do that too. Okay. I don't want to take away and say stuff that I worked on. So I want to hear. So start. I'm sure we'll have questions while shit's going down.
Some basics to cover with cannabis, right? The first one is that the plants will remain vegetative, right? They won't grow flowers until the light cycle changes to 12 hours on, 12 hours off, right? So the light load is dictated by what age the plants are. So as we get into like fruiting or flowering, right, heavy loads, we're going to be on for 12 hours a day, off for 12 hours a day.
But when they're in vegetative stage, some people will run lights 24/7. Some people will do a 16-hour cycle, lights on, 8 hours off.
Is that dictating how tall and how thick the stock is going to get with the vegetative stage?
Yes, it's all about days in veg, right? So they're trying to mimic outside. We're trying to mimic the seasons of the year. So veg is supposed to be like spring, where we have longer days before we get to the equinox. So the longer it sits in that period, the longer it'll grow, the bigger it'll grow, right? If you're really pumping out plants and you don't want them short, some people only spend a few days in veg, right? 1 to 2 weeks, get them going.
Them going and then go in the fruit cycle, essentially.
Yep. And that's 12 hours of light on, 12 hours of light on. So we have two very different like periods of the day where we're just pumping in an outrageous amount of artificial load. Right. The shell is barely any of the load. Right. It's a structure in a structure with no windows with good insulation. So
do they do anything where it's half dug in the earth? Because that would actually make a lot of sense where like they would dig down in deep where you're essentially using almost like a ground source heat pump. So you get a little bit of air conditioning from there. So you wouldn't have to use so much artificial mechanical cooling. You know what I mean?
Some of the greenhouses, they'll dig those out. Greenhouses get fancy where you can have tarps that can open and close to maintain that 12 hours of light, 12 hours of darkness to keep everything on a cycle when you want. So It's more common for like a greenhouse to be sunk. A lot of the cannabis buildings are just built up in buildings that were already existing, right?
Yeah.
Very few people bought a plot of land and did a really nice floor plan and a structure. A lot of them are buildings in a building and they're making it happen. So
old mechanic shops, that kind of stuff.
Any specific insulation that they're doing for the outside exterior? Are they using walk-in panels? Or are they just going down dirty insulation, or what are they doing?
It depends on when it was built, right? So if it was built right when cannabis legalized, it's made of drywall and mold. If it's built recently, they do a lot more like walk-in panels. They're white instead of silver, and you can clean them with a hose.
Pressure washer.
Yeah, but they have huge insulation values. And instead of modifying the actual structure, usually you just have a building in a building. So the actual load inside of there is pretty negligible as far as the shell goes.
Okay.
Then it's all about how many lights, right? The lights are nowadays in Colorado, everybody is switching over to LEDs. The power company is rebated it into reality.
They're giving away money.
But I thought, so I know from friends that high pressure sodium lights are the lights that they typically, don't laugh, Kevin. I'm like, seriously. So high pressure sodium lights are typically the lights that they use for growing cannabis. I read, what does that look for?
Yeah.
So
they have been and still are to a lot of people the absolute standard, right? And that's a 1,000 watt or 1,200 watt fixture. But right now the power company is giving away money, right? So it's like per watt rebates, plus they'll pay you to put them in and you can do it yourself. And so like these LED lights right now are free. Right?
So is it the same type of light though? Like the orangish light that the plants dig, or what?
So now LEDs, they're like full spectrum white. They look like a regular white. There aren't a lot of the purple or blurple lights anymore. That was the early stage of LEDs. But yeah, what some of these fixtures are huge and power intensive. So a lot of people think that going to LEDs is going to save you power, but it's definitely possible to put a 1,500 watt fixture, LED fixture in for a 1,200 watt double-ended high pressure sodium lamp.
Okay.
But LEDs have advanced so much. There's brands out there that can mimic every season. There's a sunrise, a sunset. There's all kinds of different settings that you can do.
The LEDs let you really go full spectrum. Like you can hit a button and make it summertime in Jamaica, like the reds and blues and just the right, whatever's important to the cultivator. Like it's absolutely possible. But this big rush to switch to LEDs has shifted a lot of the load and taken a lot of that sensible heat away, because there used to be these giant, they were heat lamps. They were just radiating heat. Now we're getting much more light per watt, but we're still putting that heat into the room. So the ratio of sensible to latent that used to be much closer balanced is shifting in a lot of these places to being heavy latent, right? Light sensible.
More moisture that you're putting in. There's not so much heat coming off those lamps. High pressure sodium lights give off a lot of heat, and they usually required a lot of ventilation because it would get so hot that it would burn the plants. So like you'd have to blow that air out in order to compensate that.
But the commercial environment wants you to see, they want to see like odor compliance, right? So you got to carbon filter everything that goes out. And a lot of these guys are enriching their environments with CO2. So they're purchasing CO2 from a company that brings it in a truck every month, fills it into a giant bottle, and disperses it through pierced hoses throughout the facility to keep the parts per million in the like 1,200 range. Again, something a grower can tweak with. Yeah,
no, that's fine. But 3,000 to 8,000, 3,000 to 5,000 is where you start feeling funny in the head if the concentration gets too high.
So we have a lot of like interlock systems, right? Because if you're going to put that in, you got to have a sensor and interlock with a fan that can purge for life safety. But that CO2 is expensive, so that limits how much they want to actually do like air exchange ventilation. It's an energy consumption is ideal, but if you're paying for CO2, you're going to want to seal the room up, and it just adds even more to that total.
Do you guys ever deal with CO2 generators?
Yeah. So it started with like little burners where you just have like gas burning in there. A lot of
no CO2 generators, like they actually pull CO2 out from the air to actually make CO2. We can talk about that later. No,
We
I
don't
know.
have anybody using that here. I'm sure some of the newer states coming on and the newer facilities are going that way. We've talked to a few companies though
Yeah.
that are doing that.
At a couple trade shows, we've seen the idea, but we haven't seen anybody pull the trigger and implement it.
Yeah.
They just pay the outrageous monthly fee for somebody to come fill their bottles up every month.
Because so if you ever seen those bougie freeze joints where like you go in and it's supposed to help your muscles and your bones or whatever, where you step in a chamber for a little bit, liquid nitrogen, but they can do the same thing, the same process, and cultivate CO2 from that and then inject that CO2. Now they do just in the air, or they actually put it in in the soil.
Interesting.
No, they're just pumping it into the air in the rooms.
Oh, okay.
Sometimes you'll see it pumped into the back of a unit for a unit to disperse it, but
Yeah, the same companies that fill up the restaurant CO2 fill the same contracts, right? So the same big old machine that fills up all the bottles in the back of a fast food joint, on their route, they come service all the grows and just fill up these giant CO2 reserves.
Yeah, I met a guy yesterday at a gas station. He was filling up the CO2 at a 7-Eleven. I was just curious. Stop it. I was curious, like, what the pressure was in the tanks, so they keep the trucks at 325 psi so they can fill those tanks up. Because I didn't know if they had a refrigerated unit on the truck to keep it so it doesn't pop off, but they just have a manual relief on those trucks. So if it reaches a certain pressure, it just sprays off. So that's why sometimes you'll see them going down the road and they blow off.
interesting.
So a lot of these grows, we have a lot of different types of equipment out there too, right? So walking into a grow, we wish that everything had very dedicated purpose-built equipment, right? That had extra reheat coils that could move all of our condenser heat around, right? That can do some built-in dehumidification. A lot of grows were built by somebody's cousin, and they get 300 5-ton units and just slam them in every which place you could ever possibly slam them in. So some facilities are very poorly designed. Some facilities are very nicely designed, where we'll have like chiller plant and a lot of water coils and things like that. So it really runs the gamut. There's not like this is the way to do it. Everybody is an expert and they all want to do it their way. So
if you had your way, would all the coils be coated?
Yeah.
Absolutely.
Yeah.
Like condenser coils and evaporator coils, just because when they make the compost, the ammonia in the air just eats everything up.
Really?
yeah.
So it's eating the coils?
Yes.
Growers are aggressive.
They spray different things during the cycle, one being aggressive sulfur to help the plants grow. So we have a whole facility where their coils are just popping holes left and right.
Yeah.
When they
spray sulfur and even burn sulfur, it'll turn all the copper black and start to really eat into everything.
What about using like stainless coils?
Yeah, no one's going to spend that money if they're installing 5-ton splits.
Oh, yes, that's true.
I mean, the purpose-built equipment does, right? There's a lot of different companies that make equipment for this, and some are private labeled of different things. But if you're going to spec out a piece of equipment piece by piece, stainless steel coils is absolutely the way to go. Reheat coils is the way to go.
Stainless steel heat exchangers.
So what are they doing for the reheat? All right, like I know you said they use hydronic, but on some of the rooftop units, a lot of times they'll use a discharge gas with a 3-way valve to basically just reheat. Is that what they're doing mostly with the package style unit?
If it's a package style unit, yeah. So the suppliers like to sell those units, like the humidizers, different like brands of unit that can dehumidify. Mm-hmm. It's a tall order to dehumidify that way with direct expansion when it's like -10 outside. The units don't love to work great in the winter, but they do remove a lot of moisture, and it's all internal with exactly like you said, the 3-way valve. Some of them are more basic where they'll just have a 4-way valve and a couple solenoids and move around where the refrigerant is going, whether it's in subcool mode or reheat mode.
Mm-hmm.
But those only work to 40 degrees, 45 degree ambient outside, and we need cooling and dehumidification.
There's a lot of makeshift reheat out there too, right? There's a lot of cannabis follows social media trends, and what's popular on social media is to slap electric heat kit on a air handler and try to match the sensible output of the heat strip to the load of the air handler, and turn an air handler into a reheat machine and just suck down the amps.
Did you ever see that meme where the guy's like, "Hey, who did your electric?" "Oh, my grandson." "When did the building burn down?"
His house burned down.
So has anyone ever used desiccant?
Yeah, desiccant's more for the dry cure space, right? So desiccant is excelling from 50% down, right? But it's hard to get a desiccant unit to compete with a direct expansion unit when you're in the 50% relative humidity and up, right? Because their performance is still crushing it. But once you start to hit 50% relative humidity, it just can't do it anymore. So desiccant.
So what's the humidity range that you're trying to in the initial grow?
So it runs through all sorts of different environments, right? So veg is supposed to be spring. We've seen rooms that go from like 80, right? So hot, humid growth. Trying to control how well the plant can evaporate water, right? If it's really muggy, the plants can't evaporate water that fast, and you can control their height. When you get into flower, the later you go, the colder and drier you're trying to make it, right? So what would you say a week 8 target is?
It depends on the grower, but there's some growers who will keep the same temperature and humidity for the entire day cycle. Others will have certain temp and humidity for lights on and a temp and humidity for lights off. So most of these guys, week 8 into flower at night, will try to run it down to 65-40. They'll never get there, but that's what they shoot for.
That's if they just get their
65 to 40%.
No, 65 degrees, 40% relative humidity.
Yeah. And if you're actually going to hit that target, you'll need some sort of desiccant.
Yeah.
But the water removal rate is out of control, right? So when we do a load calculation, usually we're just trying to set an expectation. Like, is the equipment that you have on site can it even work, right? Before we just dump hours and hours, is your equipment matched to what you do? So the loads that we do are very like, the grower puts it in and we'll take it out. So our latent load is their watering load, right? So the plant is only keeping about 2% of the water that you give it, right? Because it takes the water up through the roots, moves it through the plant, takes it out to the leaf, and evaporates it out. That evaporation is what moves the fluid through the plant. So they're always evaporating moisture all the time, right? They're not really holding on to it. They're just taking what you water and pushing it into the air.
Do they reuse that water?
In California, they do, where it's the rule.
They do not have to reuse condensate or wastewater at this point in Colorado.
Yeah, that would make more sense, because then you have a lot of the nutrients that was given off in all the minerals and stuff that you're collecting onto that. Even though you don't see them, it's still collecting it on the coil, and then you're basically putting that back in there, and then you're not reusing any of the water that you're not having to use new water, like some, right? Like you said, 2% of what your total gross sum for that watering would be then, essentially, right?
And the nutrients are expensive, so there's no runoff.
We have one facility that reclaims, but
they do. A lot of these guys, they're starting with a reverse osmosis filter, so they're stripping out whatever could possibly be in the water to begin with, and then starting fresh. So they can run it back through the RO machine if they want to. A lot of them are just concerned that it's cheaper to put source water in than to take the risk on condensate, right? These guys have been doing what they've been doing for a long time. You know what I mean? And they're stubborn on changing their ways. But
water's still cheap enough here that it's not going to convince them to add a reclaim system at this point.
Like watering in a day, right? What would you say liters per
plant? Usually 2 liters per plant is max average, which is about 4.2 pints.
2 liters per plant per day. And then you go by like how many plants per light. So it's pretty common to have 9 to 12 plants under a light. And then you'll have 8 or 9 lights deep per rack. And then it's not uncommon to have 12 racks in a room. And in order to make it easier to work, they'll put them on a library cart left and right so that there's only one walkway. Yeah. One path of egress is maintained. And then you can go a second tier on top of all those racks and do it a whole second time. So it's similar to the Home Depot pallet system that moves to the left and to the right.
Yeah.
They'll be putting in thousands of gallons of water per day, dose through a system that's feeding the plants every hour on a drip system, forcing those 2 liters per plant per day, every day.
But some of our facilities that grow bigger plants, more of a tree style, water up to 1.5 gallons a day.
Per plant, per
plant.
Damn, so you're talking the sensible heat from the lamps. You're talking about the latent heat of how much water that you're actually pumping in there. Mm-hmm. What other loads are going to be there?
The other loads are negligible. They're the electric fans, right? They're the shell heat. But really they're going to swing your load by a ton or two, or they're not going to come up nearly as big as the other two are.
Yeah.
Okay.
And that's where, if you're designing a facility, we let the engineer deal with that to get into kind of the nitpicky bits. But these guys, it's not uncommon for us to show up and they'll be like, hey, we bought 400 more lights when we hung them ourselves and now things aren't working. You'll be like, okay, let's back up.
Okay. Now, when you started,
We lost them.
You're froze.
He's got some crappy internet. He'll bounce back here in a sec.
Right of the South,
I have very little experience with this. We're starting to get like more and more grow stuff up in Illinois since it just got legalized. They're popping market. I see a lot of like Mitsubishi, like up here, like a lot of city multi-units and stuff getting installed.
Yeah.
Is that like something that's pretty common for you guys too, or?
It's more common in like Michigan and some of the newer markets where people came to Colorado and witnessed the 305-ton nightmare and considered a VRF option. So some of the brands will support, right, VRF for this application. Some of the brands will not support VRF for this application. It usually comes down to like velocity and throw, right? Because growers want, to quote a grower, they want the plants to dance. So they want enough velocity throughout the entire canopy to have air movement. It's a challenge of high wall units or a lot of the VRF.
Mid-static.
Yeah, mid-static equipment.
High static.
If you design it well, you can get it done and you can get those better throws and a little bit of duct work. But those are usually the limitations on the VRF systems, is they're just stuck with high wall heads and nothing really penetrates the canopy.
Yeah.
And it sounds like a perfect application for like refrigeration coils, like that have tons of throw.
Absolutely.
And we've had those conversations, just nobody.
We have a hard time. We got a couple manufacturers on the phone and tried to define some of the latent capabilities of the refrigeration coils, and nobody was willing to figure it out with us.
Really? It seems like refrigeration coils would be a much better choice. You get the throw, they're more durable, they're easier to change, and they got to be a hell of a lot cheaper than buying an air handler.
It's hard to quantify. Is this going to remove any latent, no latent? Can I count on it to do 25%?
It depends. It would depend on the TD of the coil.
Yeah.
Obviously, the lower the TD, I'm sorry, the higher the TD, the more moisture you'd pull out, Kev, right? I always refer, yeah. So basically, if you have and I guess it would also have to do with how many fins you have, right? The closer the fins, the more moisture capability. But it also depends on what you're trying to maintain. So you said most of these boxes are trying to maintain, you said 60 degrees or 80 degrees.
That's into flower or dry cure space.
Yeah, 72 is a good average.
A lot of people are running their VPDs higher. So like a 78 to 82, I feel like is pretty standard these days, temp wise, for the majority of flower.
I think we should spend some time trying to figure this out. It would be fun.
Yeah. Because we'd love to put them in, especially when you have two-tier environments where space is a big limitation. It would be a better install, easier to service, but it's because the dehumidification load is so big that everyone wants to know that some of it's going to be taken by the air conditioners, right?
I would like to know that, so I don't have to shove in 30 dehumidifiers into the room that already doesn't have room for equipment to begin with.
These dehumidifiers are huge, right? A 506 pint per day dehumidifier is like a 4-foot, 200-pound piece of equipment, and the manufacturer wants them to get 6 of those, or 14 320s, or 28 225s. There's no room for any of this. So any of the latent load that the air conditioners could take swings that favor. So that's where they get talked out of the conversation, because the latent can't be quantified, so they aren't a great option. But I think people would absolutely be into it if it was easier to prove what it could do.
Yeah, as we've talked to how
I would definitely think you could do the latent. It would be easy for the most part, I would think. It just depends on how you control your coil TD, and you could easily do with the variable speed fans. But it seems like the refrigeration side would be a much more robust option.
Yeah, we're often making standard cooling equipment into makeshift refrigeration equipment, where we're trying to get these pieces of comfort cooling equipment to run in negative 10 degrees. So head pressure controls, low ambience, winter bypass timers, heat tape, like better served with a receiver. They'd be better served with an accumulator. But
you could use the discharge temperature right off the discharge line, Kevin, put a shit ton of heat reclaim in there.
And then, yeah, the other thing, like I've worked with some guys like up here out of Michigan that I didn't understand this at first, but they're freezing it. Like they're blast freezing the weed.
That's popular these days for it's for the extraction, right? So traditionally you cut it, hang it upside down and dry it like it's a flower and you want it dry. But what's trendy right now is to take it and cut it and freeze it instantly and try to lock in all of the fresh flavors. And then the extraction has more volatile organic compounds to work with. It can get a higher end product at the end of the day. The extraction labs, like there's a lot of really nice equipment in extraction, and those also range all over the place. So some facilities are doing like propane, butane, hexane extractions through C1D1 extraction booths. Some people are doing, it's basically, it's rosin and you put ice water, it's old school bubble hash, and then you squeeze it with a really big hair straightener and you sell the goop that comes out.
You don't need special permits or licenses for that. So a lot of people go that way.
Yeah, so that's really trendy. But to get better product for that, you're getting more of, Kevin was saying, the fresh frozen, where they're lining the entire facility with freezers. They want a blast freezer and they want the ability to lock in these plants the instant they're harvested.
Yeah, it was super interesting like how they were doing it. They were doing it with shipping containers and used equipment and whatever they could find to make these blast freezers. And it was just like chaos, but it was cool what they were doing. It seems like a huge avenue for like refrigeration companies to get into.
And it's going to be more popular because that process is easier to automate than to have somebody like your master of dry cure needs to check in every day, every hour, move things around, get them spaced. Whereas if you can just hack it down and freeze it, that's a much more scalable process.
And you don't need skilled labor for it.
Yeah. And that's where the industry is headed right now, right? Where cannabis is figuring itself out, where it went from being everybody figuring it out to consolidation and some bigger players and some bigger facilities starting to take the lead. So
yeah,
I do think
there's pretty cool.
A lot more opportunity.
I'm even thinking about the external dehumidifiers that they put on top of coolers with high ambient. The ones that typically sit on the box, Kev, the ones that basically take return and supply for dehumidification for when docks are open a crap ton and humidity is a problem. That would be an excellent option for that as well. You could do the regular refrigeration, set it up for as much latent heat removal as possible, but then size the external dehumidifier. It wouldn't have to take up any space within the facility. You have high throw evaporators that have vast throw being able to go across. So these rooms are probably 100 foot across, yeah, if not more.
Depends on the facility, but yeah.
Yeah, so some cultivators like one big room, a lot of them smaller rooms that are easier to mitigate problems or pests in. But yeah, big old grand
I just keep
room.
thinking about all the possibilities.
There are, and it's the people that were quick industry-wise to get in on it were some of the like data center equipment, right? Like data airs, G pods, which it's a bummer they're out of business now. But those were some great intermediate equipment, right? Where we had a rooftop condenser, the compressor was in the room, so we could use the three-way reheat valve and do a much more controlled dehumidification setup. So there is a little bit of crossover from that industry, but I'd love to see the rack supermarket version of a grow. I think that'd be great.
Your energy consumption would be way down because of pressure.
This screams protocol to me.
Yeah, the energy consumption, these guys' power bills are out of control.
Yeah, it would be hardly anything compared to what it is now. It's insane for what they're doing. It seems pretty simple. You're just manipulating things and controlling things, and making makeshift units doesn't really do that.
And everything's on its own breaker. Yeah, the power is out of control, right? No one knew how to do it. So all these guys got as much power as they wanted. So they're just sucking down amperage. I think, and that's where the energy companies are interested in energy efficiency, like cleaning up some of this big consumers, which happen to be these facilities. So I think there's a huge potential for how these guys are going to be potentially saving energy.
Yeah, they want to do it with VP or VFDs and high SEER equipment, which also isn't super practical for
unit by unit VFDs isn't solving much.
But that's like the main rebate they want to give out.
Yeah.
When moisture just.
I don't imagine high SEER equipment going to last either. Probably not in that environment. with all those chemicals, all that high tier equipment is just asking to fill.
And with parts that are hard to get. That's
inexpensive.
So a lot of these guys, they want the redundancy, right? Because some guys have had bad experiences where they went with one single air-cooled chiller for their entire facility. And when it goes down, it's an absolute nightmare, right?
Because nobody knows how to work on that equipment or is maintaining the equipment like they should be, is usually the problem. Where anybody and everybody can work on a 5-ton split system.
Yeah. So
what happens when this goes down? Obviously it's food. When it's food, we throw it all out. It's bad. You're really bad. What happens when one of these grow houses goes down? So let's say it is on a chiller and it goes down. They shut down because there's overheating all the lamps, or
all the lights have to turn off, right? So a lot of the lights are on controllers that are temperature controlled. So if they start to approach 90, 92, 93, the lights are going to start to auto dim to the point where they will eventually turn off. But that's going to mess with the product. You're not going to get a better product messing with the light cycle, and you might start growing seeds, right? Which is going to devalue that room a lot. Like they're big harvests. There's big money on the line each room. So they want it fixed as fast as possible, but there's a little bit more time than there would be with a refrigerator, where like they can get the lights off, they can make it through to the lights off period, but they really need you to be here before that next lights on period.
Some facilities will keep like a portable unit to roll in just for safety backup, that kind of stuff. Some places have generators if they actually do lose power. Like we had a facility had a panel catch fire and they didn't have power for 3 days.
Yeah,
because of high winds.
100-mile-an-hour winds knocked over the power line there. So they scrambled, got a bunch of generators, got it running. We're only running just enough lights to keep the plants awake, to keep the photo periods in sync, but not enough to have to run the air conditioners. But it gets humid, it gets hot. Like it's definitely not ideal, but it's not a total loss. It can turn into one, but you have a little bit more time.
Yeah, that's interesting. It's not as bad as food, but there's still a lot on the line for it.
And that's where these guys like to do multiple units in a room for redundancy. So if one does go down, it's not the end of the world.
Or a chiller plant where you have 3 or 4 chillers or 3 or 4 pumps. So something can go down and the whole facility is not just out of luck. Redundancy is a key piece.
That's why having a rack with multiple compressor capacity, you could basically just oversize the capacity of the rack by whatever in case one compressor does go down. And then you still have just an industrial, right? You got 60 coils in there, one's down. Guess what? We have 59 now. So there's built-in redundancy in it. The only thing is that you're running more copper, but it's be the equivalent because you're controlling how much more.
Today's episode is sponsored by the RefRushield RDP series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales at westermeyerin.com. That's WESTERMEYERIN.com.
The power lines are ran, the automation would be fairly a lot easier. You could do you could do a big old heat reclaim coil right off the damn thing. And you said most of one of the biggest problems is controlling the heat within the wintertime, right? Guess what? If you run the discharge basically where you bypass the condenser that's outside and then you have an indoor condenser, so to speak, there's already your head pressure control where it's not going all the way down the toilet and you're still able to utilize the heat reclaim for that, man.
Yeah. How's the rack deal with big load swings, right? Because we have
fairly
all the
well.
lights on. What's that?
It deals with it fairly well. Like it's okay. For the most part, depending on how the controller's set up and the compressors are, like you have almost endless amounts of capacity.
Yeah, because you can select essentially what size compressors that you have. So you could have 2 large ass ones for whatever has the most heat load, like when you're running those things 24 hours, and then you'd have one that basically would be your VFD or your lead compressor, whether that takes the little bit of change in capacity. But you said these loads are fairly solid. You don't really have major
They're solid
spikes.
for 12 hours, and then they go the complete opposite way, right? Where we might need 100 tons of cooling for 12 hours, and then we shut the lights off, and we go 100% latent load, right? And even the plants are evaporating, so technically they have a negative sensible load, right? So our ratio goes 100% latent at the flip of a switch for 12 hours, and then the lights come back on, and we go full load for 12 hours. So
that's the only thing, Kev. What would you do? The only thing that you could potentially do is you'd have 2 grow rooms, right? That would be matched. And then essentially their light cycles would switch. You know what I mean? Where you could basically control large latent heat over here and then sensible heat over here and then swap them and then be able to use that discharge temperature to keep that room a little bit heated or combat it with the discharge. There's so much stuff you could do.
Absolutely. And that's how the big chiller plant systems work, where they want the rooms to switch over so that the load stays consistent. You're always fighting a cultivator, right? You have an engineer who's got a great idea, and then you have a cultivator who doesn't like to have to stay until whatever time of day the lights switch over. So they want to run the whole building at once because that's how they run happy employees, right? So
nobody wants to work third shift.
Yeah.
Hire another cultivator. Damn, but the shift, it's called shift differential. Get used to it, kid.
And that's where you got to make the engineer put the switch panel in, so they just can't do it.
Yeah.
Or rooms change over at noon, so you can catch the end of the day in some rooms and the beginning of the day in other rooms.
Yeah,
that wouldn't be bad. And then that way you'd have a constant load on there and be able to mitigate that sensible to latent heat a load. And so typically like a full cycle from veg to harvest. What is that looking like as far as the length of time? Typically
8 weeks. So when you go into flower, that first day you put 12-12 on it. That's day 1, and it's going to be ready in 8 weeks.
The veg cycle before that.
Yeah.
You're 2 weeks to 4 weeks usually in veg.
So you're talking 12-week cycle, right? And then you have harvest day, and so you're chopping everything back down. Are they replanting new seedlings, or are they just, because they know they don't want them to grow balls, right? They don't want to have any seeds in there, so they're just trying to keep all females in there, correct?
Yeah. So in your veg space, you keep a couple mom plants that never get to leave the veg space, and they just stay in this vegetative state forever, but get very large. And then they take cuttings and root all the cuttings, and that keeps your genetics the same, right? So that's how you get those same batches of whatever sour diesel or whatever is popular. They keep that mom alive, and that mom can feed 100 to 300 clones a week, depending on the size of that plant.
Damn. I didn't realize it was that much.
Oh yeah. And it's the clone space is the highest humidity, but they usually just keep them in domes, right? They're in like little plastic high humidity while they're rooting. Then they go into veg, and they start out, they were just a cutting. So they're like 6-8 inches tall. They get roots, and then they're off to the races. So depends on how big you want them. If you're 2-tiered, you can't let them get big, or it's going to get out of control. Your canopy space is very limited, so they're rushing through veg to get into flower.
They're just bushing mostly. They look like a big damn bush.
But when a flower room comes down, the goal is to get it turned around as fast as possible, right? Like this is a business at the end of the day, right? So downtime is not good time. So that's when service is supposed to happen as well. You're supposed to time these dips in their schedule, because that's the only time you can take a lot of the equipment down and do a big repair or maintenance. So
you're doing maintenance basically on each room every 12 weeks, then I'm guessing.
It depends on the facility.
They usually veg in a different space than the flower rooms, right?
Okay, so they're moving the plants.
Profit. You might have 4 tiers in veg, right? Because you need enough plants to feed your
entire facility.
Yeah, thousands of plants per room. So you just have giant rooms of vegging plants, and then as soon as it's harvest day, try to get it all harvested in one day, get it all in the dry room, or get it all frozen, clean the room, which
sometimes it's 24 hours. They will flip that room in 24 hours and load it,
and then reload it like as soon as possible to get it going again. So it's all about productivity and automation these days.
Okay.
Some people will take a good week between just to really deep clean the rooms, and they're cleaning every fan blade on their wall fans and everything like that, but not No two facilities are the same.
Gotcha. And you said that some of these are mom and pop, or they're like, hey, what single units do we have? What can we throw in there just to do it? Now, you talked a little bit about some units that are specifically designed for this, and they do have a coating both on the condenser coils as well as the evaporator coils, right?
The condenser coils are in Colorado, right? The evaporator coils are in Miami, right? They're two completely different environments. So the condenser coils aren't getting nearly as beat up, right? Because outside it's 30%, 25% relative humidity
Like 20
today,
on
70
average.
degrees, like
85.
yeah. So
Yeah.
outside it's a totally different environment than inside. So definitely coil coatings on anything in the grow room, unless it's like a packaged dehumidifier where your condenser is also in.
Yeah,
only
20% humidity.
No, it's fine. But what I'm accounting for is I don't know if they make their own compost. What I was saying before about the mushroom plant, that they made their own compost. So every couple months, I'd have to go over there and shut down the whole condenser, pump out all the refrigerant out of the condenser, and hit the braze joints, because the ammonia that was created off the fertilizer would basically seep. It would just put pinholes directly in the braze joints around all the U-bends on the condensers. And I didn't know if they were making their own compost there on site.
Not really. The testing is limiting a lot of what these guys want to do. So all the product is getting tested for mold, mildew,
Metal.
total yeast and molds, heavy metals. Yeah. So a lot of the places that were getting hit hard with failures were places that were trying to do living soils, right? Organics, heavy compost, because the plant is really good at cleaning those metals out of the soil or pulling any of that stuff out of the compost. So it's a big risk to some do, right? I don't want to say that nobody does it, but it's a true master of their craft who's very attentive, who's like, it's hard to scale. What we see more of right now is coconut core. So much coconut core because it ships compressed, right? It ships in a 1-inch puck. You get it wet and it expands to a 4-inch puck. So
you're talking about where they actually put the seedling in.
Yep. But it's
okay.
Literally, there's no compost. The soil is just shredded coconut. It's cocoa core. So everything comes down the nutrient line, right? So it's a form of hydroponics, but most people aren't like growing in a big bucket of water. They're just feeding every single nutrient has to come down the drip tube because the soil has literally nothing in it. So we see a lot more of just like giant shipments of coconut core that come in and then they're discarded at the end. Right. Yep. So the outdoor, they're not making any compost. We don't have many issues on the outdoor units as bad as the indoor units. But
and if they are using soil, it's pre-bought. It's already pre-mixed by whatever grow company.
So let's talk about some of the heady engineering that you said you were dealing with, where like you said, like the automation could be amazing and it's not. So what's going on with it?
Yeah.
We see anything and everything. A lot of facilities are still just on standard residential wall stats where it's on the wall. They don't even have remote sensors in the space to read the plants. They're reading the wall.
There's so many degrees of controls out there, but none of them are
actual controls.
Yeah. So a lot of them are, like Megan was saying, strung together thermostats where you're trying to make like a mesh out of this whole thermostat network. There is some projects we have, the chillers are all like trained chillers. But Train didn't sell the project. It was sold through a third party who white labels all of these Train chillers and matches them with the air handlers from the company who lets them white label them at AHR and matches this whole big mashup. So what they're left with is a very custom, non-modifiable building automation system that no one has the password to. Nobody knows how to get. So they're locked down on this like white label version of whatever level tracer that they were given access to at the time. Yeah. So you'll walk up and be like, oh, this is great. You have a chiller plant. Let's hone this in.
Let's see the controls.
No, forget about it. But there are some.
Pretty standard is residential thermostats with remote sensors that are Wi-Fi capable.
Also, yeah, there is a lot of the people who make the fertigation, so the fertilizer company who has to build a control system to dose out all of their nutrients midstream. So you have all sorts of little pumps and mayonnaise pumper pumps. So they build out a control automation system for them. And then an add-on is like, why don't we just control all of the HVAC that's on site? So Is there potential to do that really well? Yeah. What do they usually do? By a Modbus connected thermostat, and the two systems can yell at each other. Usually it's a one-way street, right? The main box can yell like new set point, and that is it for communication between the building automation system and the actual unit. So
some of them don't even want to control the thermostats. They just want to see it for the data purposes all in one place.
I'm utterly disgusted right now.
You'd be very disgusted if
They're like
So cheap to do it.
It would, and quite honestly, like it would. You get so you're talking about like the concentration in there. They make sensors that measure the concentration of some of the chemicals that you're talking about. If you know the range of the sensor, you could put that into a freaking input board, Kev, and you could control it. You could automate it right through there.
Oh yeah, easily.
All right,
Full tough stuff.
Quit my job tomorrow. I know what I'm going to do tomorrow.
Except you live in a state where this is the devil.
Right now in the state I'm at, it's fine. I'm in Oklahoma.
Yeah, but Oklahoma's the Wild West for sure.
yeah,
There's no rules and regulations. They're trying to implement them now after how many years?
each state is its own ecosystem, right? So
Yeah.
it's not legal on a federal level. So I like to say it's the equivalent of saying that apricots are illegal. Each state grow your own, right? So everybody has made these outrageous facilities to grow apricots inside in northern Michigan because that makes so much sense, right? So each little market has their own nuances, and some of them are really hard with seed to sale tracking and all these metrics to keep things under control. Oklahoma missed the boat on a few of those oversights and had a very low financial fee to enter, right? So there are a lot of licenses.
It was like $2,500. Anybody could have a license to grow cannabis.
Yeah.
Like insane.
Oklahoma is an interesting.
And Oklahoma is only medical. It's not even recreational. And what is it? There's one dispensary per 10 people in the state of Oklahoma or something outrageous.
Something like that.
The climate of Oklahoma is very comparable to Indiana. Like it's like the same weather. I'm sure your wife will love it. I'm sure we can come up with some crazy system and it would go just fantastic. And then we white label it and just sell it across.
They're selling control systems. These people.
They won't spend the money.
It would.
Some do.
But you'd have to show them the ROI, right? You'd have to legitimately, like you said, you probably look at one of these meters and it's just going like this. Just freaking
wouldn't be hard at that point.
And the labor saving. That's what justifies a lot of these. Because some of these guys, like the nice automated fertigation system, that's the big upgrade that they made. Because they got into the facility and they were hand mixing nutrients, right? You had a giant tank and you climb on the ladder and pour in however many milliliters of each thing and stir it up and then send it down the line and hand water every one of these thousands and thousands of plants.
And some facilities would do that 2 times a day.
Yeah. Some of them didn't include any floor drains, any water management. So all of that runoff and extra condensate was flowing to buckets, and you got to pay employees to go empty buckets. Right. So a lot of the fertigation and automated watering systems pay for themselves. So you can be like, hey, how many labor hours are you spending mixing tanks and just watering? And it gets to that ROI very fast.
And you're hoping you're mixing those nutrients the same every day.
Yeah, it seems like the building automation would be like a no-brainer just for the control of it, just setbacks and knowing when it's down. Like,
just imagine the conversation. Did Paul mix the chemicals? I don't know. We had a lot of drink last night. Let's see how it comes out for the product this week.
But some of them are automated. Like it was interesting talking to the Dosatron rep because Dosatrons are popular for all these nutrients. But he's like, bro, I sell most of these on like water towers for water treatment. The little clickety clack thing. They'll have 20 or 30 of the Dosatrons clickety clacking away, making up a custom recipe that's being fed down the line every hour.
At least the little clickety clacks have a ppm meter and they're measuring parts per million in the freaking tower, where it's just I think we'll turn it up to a 40 stroke, and for 30 seconds we'll see how that works.
God, I couldn't imagine having that many of those things. Those things are so annoying.
Then you have to have them inside because it's fucking Colorado, right?
Yep.
Because if you have them outside, they're gonna freeze, right?
Absolutely.
So you have a giant wall dedicated to clickety clack and Dosatron, the fertigation room.
Yeah, it's definitely interesting, and it's coming more and more. Chicago's starting to, Illinois is really coming around with it. So like it's starting to become a lot of our work at our local. Like I see them all over the south side of Chicago. I see grow rooms things popping up.
Kev, Wild West. That's all I'm going to say. Just Wild West. Let's go to Wild West with the $2,500.
As the new states are coming online, people with real money are coming into play in the cannabis market. So they're spending money to build it right and do it right and pay for a real engineer versus somebody who says they've done a grow before, but then you get halfway through the project and they've never done it. Yeah. Or you're like teaching somebody the difference between latent and sensible. Do you get the watering rates of these plants? Do you know how many plants they're using? Like, we often have to sit an engineer down and be like, here's some cheat sheets from the dehumidifier manufacturers, their deration charts.
That's what I was going to ask. I know you said that you're using just about 98% of the water that you're putting in. So let's just say let's do a round number here. So 10 plants. How much sensible heat? How much latent heat?
If you were under the double-ended lights, right, where you have, or like the HPS, right, your high pressure sodium lights, where we're giving off way more waste heat, we're going to be closer to matched, right, sensible latent. So the air conditioner is going to handle way more of it. Whereas if you go with an LED, you're going to be way heavier on latent, less sensible. So the air conditioner is going to shut off and not remove nearly as much moisture.
That's where like running a cold coil and reheat would just kill it.
Yeah. You could basically run and you could change the TD. Like Kev, you could use CDS valves with pressure control. So you could just change that pressure to whatever the hell you're trying to do. And then just you could maintain a electronic holdback valve to maintain the discharge pressure to add more sensible heat in there to make sure that the AC doesn't kick off.
Quit giving away all the secrets.
Yeah. The first thing we usually need to do is run those loads of the lights. So the sensible heat. So whatever the watt is of the lights times the number of the lights times the BTUs per watt.
Yeah. 10 plants is a small example. So build a makeshift room here. So 2 liters per plant.
Let's just say there's 100 lights.
100 LED lights in a room.
How many watts do you want them to be?
750.
750. So
standard LED fixture size these days.
Yeah.
We're looking at 75,000 watts there.
And that's okay.
3.412, which is a BTU per watt. So we're at 255,900. We'll divide that by 12,000. So we're looking at 21.325 sensible for the lights only.
So are you guys figuring any energy with the temperature of water that you're dumping in there?
The temperature of the water? No, we don't take into consideration the temperature of the water.
Okay.
They're usually tempering it because the plants don't like water when it's too cold and they don't like water when it's too hot. So it's usually, if they can, they're going to send it through a water heater and a water chiller on its way after the RO machine. Or if they don't have that,
other ideas for that,
they'll batch tank it up and let it come to temperature and use it the next day. So they make effort to make sure that the water is as close to room temperature as possible.
Yeah.
Okay. All right. So we got the wattage, we got the
sensible load of the lights, and then it goes to, okay, how many plants are in the room? Usually if we have 100 lights, there's usually 9 plants a light on average. So you've got 900 plants.
Holy crap.
And if we're watering at 2 liters max a day, because again, we have to take in those max considerations, like what's your lowest temp and humidity you're trying to get to, and what's your max watering rate. Because we always have to, worst case scenario.
Yeah.
That 2 liters turns to 4.2 pints a day. So that's 7.8. Is that right? 900 times 4.2. 3,780 pints per day watered in.
So we'd actually have to pull that out every day.
Yes.
Every day.
And your dehumidifier options, right? So Quest, who pivoted from supermarkets to cannabis, they're serving both. Their biggest model is
76, I think.
876 pints per day.
But that pints per day number is rated at 80 degrees Fahrenheit, 60% relative humidity. Yep. And nobody's growing at that temperature. So if they're keeping the room 72 and 55, you're not going to ever get 876 pints per day out of that unit. So we got to take into consideration their lights on temperatures and their lights off temperatures if they have them.
Yeah.
Because that's going to change. That's going to change the humidity, which is going to change. Yeah, okay. All right. Yeah. All right.
So I got to divide that, between the 24 hours and the light cycle and what they're reaching for. And usually I'll run it off of worst case scenario, which is week 8, lights off. How far are you trying to get down to? Because that's what we need to plan for.
You'd have to figure out what it's going to be in the veg cycle, which is basically matches the daylight. And then when the flowering, it's 12 on, 12 off. So then you'd have to figure out exactly how much moisture you're putting in and how much heat. Holy crap, my head hurts. I need a paper. I need a piece of paper.
Yeah.
I have to write it down. I have to, or I like to keep myself straight. But we're starting to see more and more facilities keep a consistent temperature and humidity for night and day temperature or light cycles, which is nice because it's less planning. Where we have facilities that will change temperature and humidity set points every 3 or 4 days.
And that's, because this is a new industry, nobody's an expert, right? So a lot of these facilities, you're designing around somebody who's a pro. You get that extra super deep purple if you get them cold at night. And be like, what's that based on? What's scientific? Like, I need it cold.
I might have been microdosing that week. I'm not sure.
Yeah.
And everybody's got their own way to grow. Everyone's got their ideal perfect scenario, and you can't tell them otherwise. So it's like, tell me how you want to grow. We'll do this math together so you can see that you need an insane amount of dehumidification.
Yeah. And this is where the VPD chart is what this is for. So VPD is vapor pressure deficit, and it's how easy or difficult it is for the plants to transpire water, right? Mm-hmm. So it's a measurement comparing 100% saturation of the leaf temperature and the room, and you're quantifying it into a number. So you can say, be like, hey, at this temperature and humidity, the plant is working this hard, right? So it lets you approach a grower who's asking you for something unrealistic, right? So they want 60 degrees, 40% relative humidity. Be like, no. You can plot that on a chart and be like, okay, that's actually 1.2 vapor pressure deficit, the difference of leaf pressure to room pressure. And you can work up the chart and find a more happy medium for that grower. Look, I understand you want this VPD. Let's try this other target of 2 degrees at 60%, and the plant is expending the same energy, but your equipment's going to work.
We're getting more capacity out of your equipment. But the expert person doesn't really work off of VPD. And if they do, they don't understand it as well as they think they do. So to get somebody to change their VPD on a chart it's a battle. It's an uphill battle.
They have to, though, like with this, like where we started, right? LEDs are being shoved into the market. So these guys that have been doing the same thing with giant heat lamps for 10 years, all of a sudden their process isn't working so good anymore. So they're suddenly now open to a discussion about, let's get more out of your equipment, right? Let's move your temperature, humidity set points around.
Let's stage equipment.
Yeah, to something that's going to sit better in your performance charts or your unit's capabilities instead of just the maximum low target on a thermostat and the maximum low target on a dehumidistat, because
that's all they're being controlled with. That's ridiculous. I want to talk about the freeze, but we're already at 1:07. I'd like to have you back on again to just keep going with this, because I could go for another hour, but it's already getting late. I know you guys worked all week. Kev, do you have any more questions? Because I just keep thinking about things that we could do, and I don't want to give any sauce out.
No, I'm good. It's a good talk. It's very interesting. It's definitely coming around. It's a whole nother side of the avenue for this.
Right. Hey, they're good clients, right? Some of them are, some of them aren't, but the ones that are fantastic. They know their temperatures. They know their set point. They can call you before things break. You'd be like, hey, my humidity's a little off. If you got time, come swing by.
And we try to educate as much as we can when we're on site, communicating with our customers to where we have some cultivators that they can call out what unit's broken. They can call out what even might be wrong with it, because we've worked with them so closely on some of it.
It was just like the food industry, right? If you have a problem there when you're vegging, you've now already messed up the flowering process, right? So like you've now ruined potential how many thousands of dollars for the product. So they the bigger ones, I'm assuming, are probably treat that like food production, where get here now, I don't care what it costs, just get it fixed. It needs to be up now, or I lose let's just say $100,000 worth of product. I don't know what it is per plant per sale or whatever, but it's just detrimental. Like when I used to work at a chocolate plant, I had one chiller that if it went down, it was $10,000 an hour, because it basically
they had it down to an hour. Wow.
Yeah. So they knew, because it was the bean grinding station. So if you couldn't, roasting, if you couldn't roast the bean, if that chiller wasn't working for that area, it stopped the whole process. So that means nothing else is getting done at that point. So same instance like this, where if you're not, if you mess up the veg process, guess what? The rest of the plant is garbage. Now you're starting from scratch. Matt and Megan, I really appreciate you guys coming on. That was a really good talk. Thank you, guys. Hold on for a second. And once again, thanks for coming on, and we'll talk to you guys next time.
Thanks, guys.